In this video, we're going to return to the concept of bivariate data, but this time we're going to talk about bivariate data where one of the variables is qualitative and the other variable is quantitative. So for example, you could have the bivariate data gender along with height. For example, you could have female and then a height of let's say 67 inches, and then male with a height of 71 inches, male with a height of 74 inches, female with a height of 65 inches, etc. So these are examples. This is an example of data where one variable is qualitative and the other one is quantitative. So what can we do with this? What we're going to do is we're going to use this where we do descriptive statistics on the quantitative variable, but we are going to group those statistics by gender. And so that's how we're going to approach this. So descriptive measures for the quantitative variable for each value of the qualitative variable. So what we'll be able to do is we'll be able to get the average heights for females and then the average height for males. If we had more categories, of course, we'd have more groups. So we're kind of grouping our quantitative variable by whatever the value is of the qualitative variable. And that's a good way of approaching this. So we're going to group the quantitative variables by the values of the qualitative variable. All right, we're not going to do this by hand. We're going to do this strictly using software. And so let's take a look at some data. Here we see the bank data that we've been using. Age, job, marital status, education, whether or not they've defaulted on a loan, their balance, etc. All right, so what can we do with this? What we'd like to do maybe is start talking about the whether or not the ages are different for different job categories, whether or not the account balances are different for different education levels. And so we can start to say, okay, I've got this quantitative variable. How does this quantitative variable look if we separate it by some qualitative variable? So what we're going to do is we're going to begin by copying this data and pasting it to StatCrunch and then running some analysis on it. So we're going to select all. Select all. And we're going to copy. We're going to go to StatCrunch. And since our columns had labels, we're going to paste it up where it says var1. And so there you go. You have all the data in here. So let's go ahead and let's look at the average age by marital status. All right, so what we're going to do is find out if the average ages or the standard deviations of the ages or what have you are different for different marital categories. Since this is number crunching, we go to stat, and we are going to do summary stats because we're describing the age variable, and we're going to work on the columns. So the age category, the age variable, is going to be the one we do our analysis on, do our descriptive statistics for this. But we're going to group it by marital status. So what this will do is it will give us the mean, the variance, the standard deviation, all those measures, but it will separate out the different marital groups. Let's go ahead and hit compute. So we see here for the divorced category, the average age is 45, the standard deviation is 10.12, the median is 45, the range is 58. We see we get all the data or all the information about just the divorced members of this bank. For the married members of this bank, married customers, the average age is 43.45, the standard deviation is 10.31, and the median is 42, the range is 64, etc. For those that are single, we see that the average age is 33.93, the standard deviation is 7.5, the median is 32, the range is 50. And so what happened is that we took each individual value of marital status and found the average age for each group. And we also found the standard deviation for each group. I think it's pretty clear that there's a difference in the average age. Notice that being married and being divorced, the average ages are about 2 apart. That might not be a big enough gap to be really informative. All right, so there we go. We can do this for qualitative variables separating out quantitative variables. We can do the same thing with graphs. So for instance, we can do a histogram, again for age, but we're going to group by marital status. We'll let it bin on its own. We'll let it choose its own bins, but we do want to show the values above the bars. And we hit compute. So we've grouped it by marital. It's going to create a different chart for each value of marital. So here you are. So here's the histogram for the divorced group. Here's the histogram for the married group. And if we hit this arrow again, we see it for singles. And so we get an idea of how these graphs are all different. So singles, married, and divorced. They all have somewhat similar appearances, and what I mean by that is they are right skewed. Each and every one of them is right skewed. A tail off to the right. Of course, this one has a nicer curve to it. So you can create graphs grouping by some other variables, some histograms by other variables. Here's where box plots, I think, are actually interesting, is when you have multiple groups. So we're going to do box plots. Again, age. We're going to group by marital. And we'll go ahead and we'll use fences to identify outliers. And we'll hit compute. And here's the picture. So here's the divorced, here are the marrieds, and here are the singles. This is what I mean, that I like these when we have them side by side, the box plots, because I can really see that 50% of the group that are single, have ages between here and here. But for married, it's up here. Notice there's hardly any overlap, and there's even less with the divorced group. You'll also notice that as you hover over one of these box plots, you get the quartiles, the medians, the upper limits, and the number of outliers. All right, so that was working with age and marital status. We can do the same thing, start comparing perhaps education with balance. So let's go ahead and let's get the descriptive statistics for balance, for the bank balance of people, where we use education as our qualitative variable. We'll group it by how much education they have, primary, secondary, tertiary, etc. It's the same process. We're going to go to stat. We're going to get some summary statistics for a column. This time the column is going to be the balance column. But we're going to group it by education. So let's see if different education levels have different bank balances on average. So we're going to go ahead and compute that. So we're going to find the descriptive statistics for the balance data, grouping it by what kind of education they have. Okay, so people with a primary education had an average balance of 1411, a secondary education 1196, tertiary education is 1775, and for those with an unknown education level has average of 1701. We can also see the standard deviations for each of these four educational groups. We see the median for each of these educational groups, etc. So we were able to find the descriptive statistics for the bank balance broken up by the type of education they have. And we can get the graphs for this again. go ahead and do a histogram where we do bank balance, but we group by their education. So hit compute. There are the bank balances for primary education, secondary, tertiary, and unknown. All of them right skewed. We can also get the box plots for these. So go to graph, box plot. We're going to do bank balance, and we're going to group it by education level. Hit compute, and here are the box plots. Because of the extreme outliers, extreme values, we've got some, hardly see if there's any overlap. So that's what we want to look at when we talk about bivariate data, where we have one variable is qualitative and one variable is quantitative. We use the qualitative variable to group the other variable, the quantitative variable. So the qualitative gives us the groups, and then we can calculate the statistics and find the graphs for the quantitative variable based on the qualitative variables groups.